Well, hello. My name is John Stultz, and I work for Lenore's Consumer Group. This session is going to be an interview kind of conversation style session. So please save any questions, and we'll see if we can get to any of them at the end. That said, it is a short 25-minute session. So if you do have questions, do feel free to ask questions in the Slack chat room. And then maybe later today after the session, Todd and I will be able to try to answer those. So with us today is Todd Kjos, who works at Google on the Android kernel team, focusing on their recent efforts with the generic kernel image, or GKI. Todd, it's really great to have you here for this conversation. Thanks so much and welcome.
Glad to be here.
So I guess let's start off. At a very high level, can you tell me a little bit about the goals of the generic kernel image effort? What is it and what's being done? And why is it being done?
Okay, so there's a number of goals, but the overarching main goal is to deal with the kernel fragmentation problem we have. And the problem is that vendors take our common kernel and they add their secret sauce for their SoCs to it, and then OEMs take that and they add their changes, and the result is that pretty much every SKU of device out there has its own kernel. And that's what we refer to as the fragmentation. The issues that come out of that are that security updates become very labor intensive. If you can imagine, to get an update out there, thousands of kernels have to be updated with whatever patches are needed for that security issue, and then those need to be deployed to the field. We're wanting to move toward a world where these kernels are kept up to date with LTS, and so we want merges of LTS to come down. And the reason we want to do that is because we have found that a very high percentage, over 90% of the security bugs that are found, are already fixed in Android Common by the time that they're found in the field, and that's because we're keeping it up to date with regard to LTS. And so we want to keep these kernels flowing and getting updated, and the fragmentation is really in the way of that. And so that is the driving issue that is motivating GKI. There's other things too, like cleaning up the ecosystem code, where right now there's a lot of kind of expedient changes that have been made in various of the kernels, and by doing GKI, we're making it easier to merge LTS by aligning more closely with upstream in terms of the core kernel, at least, and pushing the changes that are specific to SoCs and hardware out to vendor modules instead of having it in the core kernel.
All right, so I guess moving to this kind of more modular style kernel, how does this effort kind of differ from modular kernels that Linux distros have been using for decades now?
I think the big one is that we're, as I mentioned, it's motivated by security updates and being very aggressive about it. And what we really want by using LTS updates is to get the fixes out there on devices before they're even discovered. So we have found with our Pixel experience that oftentimes when the exploits are found and reported, that we've already got the fix, that the exploit could not have been done on a Pixel phone because it already has been updated. And there's a few others in the ecosystem who have been with us on that, but for the most part, the devices are not updated, and so then they're vulnerable. If you look at the big distros, they do not take LTS. In fact, they don't even choose the long-term supported kernels to do their distros based on. They rely on the CVEs being, security issues being identified and fixed, and then taking those specific fixes. And so there's this sort of fundamental motivational difference between the two. And so in there, another big difference is that we know who our consumers are, and so we can do things like have our partners submit symbol lists, so we know which symbols that are part of the Kernel ABI are actually used. And so those are that subset, instead of maintaining 30 or 40,000 exports as stable, we can just maintain a small subset, a small number of thousands as stable, as opposed to Red Hat, where they maintain the entire namespace of exported symbols as stable, which makes it very hard. It makes it impossible for them to just take LTSs, and so they don't, and they are very resistant to change because they're maintaining such a large, complex surface. So those are a couple of the differences.
So yeah, I guess kind of digging a little bit more into that, touched a little bit on it, but in the upstream kernel, there's been this big to-do about the fact that, the kernel does not have a stable kernel ABI. And there's a documentation file named stable ABI nonsense that kind of outlines this rationale. So, kernel modules are kind of classically tightly tied to the kernel that they're built with, and you can't just kind of mix and match. So how do you manage to keep these vendor modules working with the generic kernel as that generic kernel gets updated?
Okay, so there's kind of two main aspects to that. The first is, one of the things that can change the ABI is the build tools. And so one of the things that we are doing is we have what we call a hermetic build, where when you check out the kernel repository, you check out, in addition to the Git repository of just the kernel, we package it as a repo with several repositories that include the tool chain and so on. So when you build it, when partners build drivers, they're building it with the exact same tool chain that we have, and we maintain that very carefully. We also have a bunch of tools that began at Red Hat for similar purposes that are watching the ABI. So we describe the ABI, and it can catch changes that affect any of those symbols that we are maintaining as stable. And we have that baked into our pre-submit process for the kernel, so that we can, once we've declared that this KMI is frozen, we can detect any change that is going to break it. And obviously we don't take those changes. They either have to, just be dropped or refactored so that they are compliant to the KMI definition. I should define my terms. So KABI, Kernel ABI, is the full surface that drivers have access to. We trim that down, as I mentioned, to just use the symbols that partners actually rely on, and that is our kernel module interface, KMI. So when I refer to KMI, it is the subset of the ABI that we are actually maintaining as stable. And just to refer back then to your stable ABI nonsense, the writer of that article was Greg KH, and he is actively involved working with us on this, and he is supportive and does believe that this is going to work out. So,
nice. So I guess what sort of impact does the GKI have for Android device and SoC vendors?
So there's kind of a large impact on, especially on some of the internal processes, because as you can imagine, with the frozen KMI, that does restrict that takes away some flexibility that vendors may have to do, and it forces them for changes that are absolutely needed in the core kernel. They really have just two options. One is to send them upstream, which is the preferred option, and we are often recommending that. And if you, over the last year, as we've been working on this with vendors, there's been a huge uptick in vendors submitting code upstream to be included in the core kernel. And in fact, it's been one of the things that's been really awesome is to see cases where Qualcomm, or I'm sorry, where one vendor will ask for something. I'm not going to be specific here, but one vendor will ask for something, and as we look, they find that another vendor has already submitted what they want upstream, and they say, "Oh, cool, we'll use that." And so we're already seeing kind of synergy in some of this. Now, there are cases where stuff can't go upstream, and there's a number of reasons for that range from schedule pressure not allowing us to wait for the time, in which case we sometimes say, well, submit it up there and we don't have to wait for it to land necessarily, but we want to see the discussion. To other cases where the changes really aren't going to fly upstream, and the examples of that are kind of in the domain of out-of-tree kernel modules, which are very much discouraged upstream actively inhibited in some cases. Whereas this is actually something that we are encouraging at our level, because what we're looking to do is to push the proprietary code that's been in the core kernel to support hardware and so on out into vendor modules, and just the timing is such that all that stuff can't go upstream first. So to support all of that, their second avenue, in addition to upstream, is to submit directly to the Android common kernels. And so if you look closely, you'll notice that our number of out-of-tree patches in some of the Android common kernels has gone up significantly through this process. So we think of that as we're taking a lot of the technical debt that exists in the ecosystem, and it's getting pushed up in and being made visible in the Android common kernels now, where ultimately we're going to start working off that debt and either getting it upstream or dealing with it in some other way. But for partners, there's a pretty big impact in their processes and how they do things, and there is some complexity in maintaining and adhering to the KMI interface that we have that has to be stable once we have frozen the branch.
Alrighty. So with Android 11 just recently released, kind of where's your team with the GKI effort? Are folks going to be finding GKI kernels on their Android 11 devices within the next year or so?
Well, you'll see within the next year, you'll see evidence of it, but you won't see true GKI kernels, because what we're doing at first, and what's happening right now, is in Android R, which just went public. The GKI, it's what we're calling GKI 1.0, where the kernels that ship as products are not our GKI kernels. They're product kernels from the vendors, but they have to pass compliance tests with Android R if they're. This is true of 5.4 kernels and higher. So if it's below 5.4, it's not GKI at all. But for 5.4 kernels at all and higher, or 5.4 kernels on R, they have to pass a compliance test for the certification that replaces their product kernel with the GKI kernel, and they have to pass the VTS and CTS tests with it, and then their devices can ship. Which means that the product kernel is compatible with the KMI that we've defined. And so what you will see in the field are devices that you could replace the kernel and the kernel with the GKI kernel, and you could replace the system image with the GSI system image, and that should be a usable device.
Okay. So do you have devices that have passed that compliance step already?
We don't. There aren't any in the field yet, but there are some that have passed. So the 5.4 kernel, the devices with 5.4 kernels haven't hit the streets yet.
Okay. I guess, do you have any kind of details of issues that vendors are hitting and trying to comply with the GKI conformance requirements?
Well, I think the biggest one is just the changes I already alluded to with regard to their development processes, and if you're used to just being able to go hack up some patches and put them in the kernel, and now you have to go through a review process with either upstream or Android common or both, that looks like friction, and it slows you down, and so the process has been have been getting adjusted, but I think it's been certainly a pain point. And another, related to that is some loss of flexibility or perceived loss of flexibility. There's really no loss of flexibility if they're trying to do some kind of value add that can be isolated into a vendor module. But if they have a vendor, some sort of a value add that is part of that needs changes in the core kernel, again, it becomes heavier weight, and so there's, we're sort of working through, and we're adapting too. So it's kind of been a learning process over this last year with our partners to sort of get to how do we complete this in a way that works for all. And we've learned a lot, and a lot of things have changed, and a lot of assumptions weren't quite what we thought. Um, the other, and then the other complication is just the restrictions that come with keeping their product kernel up to date with regard to the KMI as it changes, and you know, the potential for merge conflicts when LTSs come and so on. And so we've been kind of working through that with partners. But those have been the biggest things.
So, I mean, it's obviously very early days, but, you know, in practice, I guess, how has the kernel ABI stability gone so far? You know, has there been any kind of surprises where some small change ends up having a big KABI impact? And what have you done to kind of handle that?
Yeah, so there have been some surprises, you know, sort of dealing. So we leave mod versions on because it's very valuable to catch. So we have, as I mentioned, we have these tools that catch it at the source level, look at analyzing the impacts of ABI, but sort of the final check is mod versions rejecting a module if there's a CRC difference. And we've had a bunch of surprises in that domain where just sort of the way things are declared, where the interface hasn't actually changed, but the visibility of structures maybe has changed, changing the CRC for a module even when it doesn't look like the interface has actually changed. And so there were a number of issues in that regard where we thought we were maintaining stability, but in fact the CRCs were changing. And so we've had changes in tooling, we've had changes in process to deal with that. And I think we're mostly past those sets of issues. And we do have, so right now we have one branch which we are maintaining KMI stability on, which is the Android 11.5.4 branch, which is basically 5.4 for Android R. And I would say generally it's been going pretty well in terms of, for example, merging LTSs. That has not really had any significant difficulty with it. It's a potential, there's certainly potential difficulty where some patches that are part of the LTS could affect the KMI, and our approach to that is to either, you know, in some cases we can drop the patches because they may not be relevant for Android. In other cases, they have to be refactored so that they are KMI compliant. And in order to facilitate that, before we froze the branch, we went around and added a bunch of structure or elements and key structures that could be used for that kind of refactoring. But generally, it has, you know, has gone pretty well, and we haven't had huge issues.
Nice. So I guess, you know, what are the next steps for Android 12 and after? I mean, what plans are there beyond just the conformance testing?
Yeah, so Android 12 is where we go to our what we call GKI 2.0, which is where GKI kernel is actually shipped as the product for on these devices. And so that begins with 5.10 or whatever is this year's LTS. It looks like it's going to be 5.10. So that looks like it'll begin with Android 12 and the 5.10 kernels. And so the big challenge going beyond, you know, to ship it as a product compared to just the compliance testing that we're doing in R is that now it has to have all of the product polish. It has to perform. It has to have good power characteristics. We have to be more mindful of the size of the image and not bring in you know, unnecessary drivers that consume memory and aren't useful. So all of these are, you know, these are the main focus for GKI on the technical side. And then there's a lot of process work as well with partners as we're working out how to deliver it, how to deal with, you know, the need for rapid bug fixing and that sort of thing. So there's a lot of complex process work as well. So that's going to keep us pretty busy for the next year.
I guess, is there any issues that you're particularly worried about for the next step that vendors should be kind of watching out for as they make their plans?
Yeah, well, I guess I mentioned the performance and power, and I am one of our areas that we're watching and figuring out how to get good feedback is, making sure that when we deliver an update, say the next LTS with the GKI kernel, how do we make sure we haven't regressed some corner cases? I mean, there's kind of the obvious corner cases or the obvious cases we're going to catch up front because it'll be well tested, but some regression that only affects certain hardware and certain use cases, getting the test matrix such that we can catch stuff like that with the help of our partners. I think that's sort of, it's not completely figured out, and there's some concern there of how do we get there. I do believe we're going to get there, and we're kind of, but it's not something we can do by ourselves because we're not going to have all the SKUs of all the devices. It's something we need to do along with the whole ecosystem.
So now, I guess while being able to kind of update kind of the core kernel is going to be like an amazing improvement for security. When you do kind of look at the monthly security reports, there still are a lot of issues that are in vendor-specific drivers. Are there any kind of GKI-related efforts that you're thinking about that would help kind of close the gap there as well?
So for now, that domain of fixes that need to be applied to vendor modules is really in the domain of the vendors and the OEMs, as it has been. So I see us focusing on that once we sort of get over this first hump, and then working out how do we streamline the delivery of fixes for vendor modules as well. So for in the short term, I see that as something that we're really encouraging, just like we're encouraging today, for OEMs to do updates of that. But that one is that's sort of the next round of the security issue.
Okay. So I guess another aspect I'm kind of curious about is like, how much is a vendor going to have to be involved in participating with kernel updates with the generic kernel image? For example, if a vendor essentially abandons a device, is that device still going to get kernel updates, or is the vendor always kind of in the path for the updates?
So the vision, and I can't comment on how long it will take to get to the vision, or precisely how the vision is going to be realized. But the vision is that they would not have to participate at all, that it could be delivered directly by Google or via the OEMs, via some mechanism that that participation could be very light to nothing. That will take a little time.
Yeah. Alrighty, so that's I think all my questions. So Todd, I just wanted to say thank you so much for joining us and sharing your thoughts on kind of the recent and future directions of the Android kernel efforts. It's been really exciting to hear about it, and it's been really exciting to have Lenaro kind of be a part of the effort as well. So thank you so much again.
I mean, it's been awesome to have your partnership in all of this. You've contributed quite a bit.
Alrighty, maybe we've got 2 minutes. I don't know if we have any questions. I can take a peek real quick. Question is there a possibility any GKI1 devices get bumped to GKI2 by the vendor?
Very unlikely, and that would mean going from a 5.4 kernel to a 5.10 kernel, which making such a transition is extremely rare in our world, at least at this point. But we do expect further down the road that changing the major version of the kernel on a device will not be so difficult. When you imagine that the core kernel doesn't have much vendor-specific stuff, and so it's really just rebasing the drivers, which isn't trivial, but is a much simpler problem than it is today. So we do expect that will be something that can happen. And if we look way down the road, we hope to actually trim the number of Android common kernels that we have to keep live because they can move forward on the major version as a result of this GKI work. But again, that's way down the road.
Alrighty, well, thanks so much. I think we're out of time. So again, thanks for joining. I really appreciate it.
You're welcome. Thank you for having me.